Hello! In the experiment, I would like to examine a few of the most interesting properties of plasma. In order to do this, I will use a plasma speaker device constructed by myself. After attaching the phone, which is our source of sound signal, and setting the parameters, I will play the song. We are able to hear clearly the sound coming from the spark between the electrodes. The song is recreated by the plasma arc. This unusual phenomena can be explained. The arc between the electrodes, which is our plasma, is created by the high voltage. It is generated by the flyback transformer that can be simplified to normal transformer with a very high converting ratio. The constant frequency square wave steering the transformer and inducing the high voltage is adequately modulated, stretched and shortened. This results in condensations and rarefactions of plasma, which is heard by us as an acoustic wave. The plasma speaker perfectly resembles the high-pitched sounds as the arc membrane has small inertia. Due to its small size, the arc does not recreate low-frequency sounds, basses, requiring greater oscillations of air. Observing the first process, we could witness an unusual recreation of sound by plasma under the shape of an electric arc. Moving on to learn another property of plasma, a candle is put in the arc. You can see that the candle tip is rapidly lit and the flame is unusually shaped, covering with the plasma arc. Additionally, when we turn on the song, we may notice the flame can also be modulated. Our plasma has a very high temperature, about 7000 Kelvin degrees, which may be proven by the stronger emission of light. This is due to the additional heating of carbon molecules. However, a normal flame is too cold to be called plasma. It is an argumentative case between physicians because of the similar reactions to phenomena. Having observed plasma for a while, it may be said it has the highest internal energy. After conversions from solid state to fluid and gas, which happen with delivering of the energy, the last state of matter is plasma. This confirms our assumptions that plasma is the most energetic state of matter. To analyze the structure of plasma, I will affect the arc with a ferrite magnet. Slowly applying the magnet to the plasma from various directions, we observe that it is attracted by the magnetic field around the magnet. Independently from the side the electric arc is attracted. This helps us understand that plasma consists of electrons and ions which are susceptible to the magnetic field and create their own while moving. Then plasma might be defined as a cloud of these particles and confirm associated effects within it. To acknowledge another forms of plasma, I connect an energy-saving light bulb without a corpse to the electrodes. When the connection is present, the gas inside the bulb is ionized and cold or white warm light is emitted. From this comes a conclusion that depending on the environment the plasma is present in, it can have different properties which change with pressure, temperature and gas of course. We divide plasma into two types, the cold one, which is created in our normal conditions, and the hot one, which builds the stars. Knowing the usage and forms of presence, we are able to say that plasma is not so rare at all. In the end, to confirm that plasma is a highly ionized gas, I will use a Jacob's ladder. After switching on the speaker, we are able to notice that arc rapidly moves up from the beginning of the electrodes and later moving up stretches to break in mid-air. The situation repeats. It is happening because of the convection phenomena that explains the movement of hot air and our arc. It points us to the fact that plasma is a state of matter quite similar to normal gas. Presented examples have allowed us to learn a few of the interesting properties of plasma and acknowledge this phenomena better. I hope that I have interested you with plasma, and those are not the last properties of plasma that have been discovered. Thank you.